Hello everyone, I welcome you all to this class. This is mathematics class, and today we are looking at this topic, first order linear ordinary differential equation. We have introduced this concept, ordinary differential equation, in our previous video, but today we want to start solving problems under on this concept, ordinary differential equation. So today we want to start with first order linear ODEs. So we have the general form of the first order linear ODE. The general form of first order linear ODEs is given by y prime plus p of xy equals q of x. Now this the dependent variable is always the one having the derivative sign. So I that I used y as the dependent variable here does not mean that your dependent variable will always be y. Your dependent variable is always the one that has the derivative sign. So in this expression, the one that has derivative sign is y. So y is the dependent variable. Y, the other variable, which is x, is the independent. This p of x is the function of what? The independent variable, which is multiplying your dependent variable y. And this p of x could be a constant function. It could be a constant function. So it could be just 1, it could be 2, it could be a polynomial function, it could be sine function or cosine function, as the case may be. Then this q of x is a function of the independent variable alone. So that's this q of x, which can be 2x, 3x, sine x, cos x, exponential x, and as the case may be. It could also be 0. That is if the ODE is homogeneous. So let's consider example under this. But before we look at that, we say that the integrating factor you are going to use to solve problems under first order linear ODEs is exponential integral of p of x dx. So before solving it, this first derivative of the dependent variable, make sure that the coefficient is 1. Remember, we are talking about first order linear ODE. So the highest derivative we should see is just first derivative. So the coefficient of that one having the first derivative, the coefficient should be 1. If it is not 1, you divide the ODE by the coefficient, so that the coefficient of that one having the derivative sign will be 1. They asked us to solve this problem. T x prime plus x equals 2t. Now the one that has derivative sign is x. So in this problem, x is the dependent variable, while the other variable, which is t, is the independent, right? Now let's start this solving. Solution. Let's start the solving. Now we are given tx prime plus x equals 2t. This is what is given to us, right? Now, like I said, the coefficient of the one having the first derivative sign should be 1. So see, the one having the first derivative sign, we are having the term having the first derivative sign is this. What is the coefficient of x prime? Is t. So this coefficient of this one having derivative sign should be 1, but we are seeing t there. So what do? You divide both sides by that coefficient, making sure that the coefficient is 1. So we divide both sides by the coefficient. So this implies, divide here by t, you have x prime. Divide this place by t, we have plus 1 over t x. Divide here by t, you have what? 2t divided by t, you have 2. If you divide this x by t, you'll be doing x over what? T. But x over t is the same thing as 1 over t multiplying x. Is it not the same thing? 1 over t multiply x. X will surely multiply this 1 at the numerator. You now have x over t. So that's why I decided to write it like this, so that I can put it in this form. Then the integrating factor if will be equal to exponential integral of the function of the independent variable, which is that function of the independent variable multiplying the dependent. So in this problem we are solving, what is that function of the independent multiplying independent? If you compare this equation with this equation, you find out that your function of this p of the independent variable is this 1 over t. Then this 1 over t is the function of the independent variable multiplying the dependent. So this will be equals to exponential integral of what is that p of t. If you compare this place and this place, this is the function of what? The independent. Remember, the dependent is x in this situation. The function of the independent is this one. That's 1 over t dt. So this will be exponential ln of t. Now, whenever you are integrating a function like this, integral of f prime of x over f of x dx, the result will be ln of the denominator, ln of f of x. That will be the result. For instance, if you have integral of 2x divided by x squared plus 2. Now this formula I wrote down here, integral of f prime of x divided by f of x, is telling you that if you are integrating a quotient, that's a function in fraction form, a rational function, if you are integrating it, if the derivative or the denominator if you differentiate the denominator and you are having the numerator, then the result of the integral is the ln of the denominator. Now looking at this thing I wrote down here, if you differentiate the denominator, if you differentiate x squared, you get what? 2x. If you differentiate this 2, the derivative of a constant is 0. So generally, if you differentiate this denominator, what you are going to get is just 2x. That 2x is the same thing you have at your numerator. So it's in line with this. Derivative of the denominator is giving you what? The numerator. Then the result of we're supposed to have the x here, right? Then the result of the integration will be what? Ln of the denominator, ln of x squared plus 2. So this thing is just illustration that I gave here. Now looking at this integral of 1 over t dt, right? Now the denominator is what? T. If you differentiate t, what will you get? 1, which is the same thing as what you have at the numerator. So the result of this integral will be the ln of this denominator, ln of t. So that's why I wrote that. Now, if you have exponential ln and exponential, they are inverse function. That means exponential ln and exponential will get cancelled. They are inverse function of each other. So ln, when exponential will cancel the ln, what will be left is what? T. So our integrating factor is what? T. Now we are going to, let me call this equation, this one we wrote here, equation 1. You now multiply this equation 1 by the integrating factor, which is our t. Our integrating factor is t. So if you come here, multiply x prime by t, you have t x prime plus multiply 1 over t by t. I want to multiply this 10 by t. You'll be doing t multiplying 1 over t x. What will happen? t and t will get cancelled, remaining your x. So we have x. So then equal to 2 multiply t, we have 2t. So we have multiplied both sides by what? T. This will imply this left hand side will give you the derivative of the product of the dependent variable and the integrating factor tx. Now when you have multiplied both sides, of this equation by the integrating factor, everything you have at the left hand side is the same thing as the derivative of the product of the dependent variable and the integrating factor equal to 2t. So if you want to verify it now, differentiate tx. No, x depends on t, so x is just like x of t, right? So if you differentiate, use product to differentiate t and keep x, you have x. Because if you differentiate t, you get 1, you are keeping x. Plus differentiate x and keep t, you have tx prime, right? So this thing is the same thing as what you have at the left hand side. So after that, the next thing is to integrate both sides. So if you integrate both sides, put integral sign here. We have integral of the derivative of the product of the integrating factor and dependent variable to be equal to integral of 2t dt. So with this, I've integrated both sides. I put integral here, So the integral now will cancel the derivative, remaining this quantity here, right? Integral will cancel the derivative, remaining this quantity inside, tx. So what we will now have is tx equal to, if you integrate 2t, what will you get? If you integrate 2t, you will do, what's the power on t? Power on t is 1. So you add 1 to the power and divide by the same, right? So that's t raised to power 2 divided by 2. But we have 2 earlier here, so we have 2 t raised to power 2 divided by 2. So 2 and 2 can get cancelled. So you have your t squared. So we have t squared plus the integrating constant c, right? So make x the surface of the formula. I want to make x the surface of the formula. I will divide both sides by the coefficient of x, which is t, by t. If you divide here by t, you have x left. So, and divide this place, divide t squared by t, you have t left, plus divide c by t, you will be having c divided by t. But this c divided by t, it is same as c times 1 over t. C divided by t is same as c times 1 over t. But 1 over t, it can be written in indices form or index form as, this will be c times t raised to power negative 1, because if you return it to the index form, you will now introduce a negative sign on the power of t. The power of t is 1. Introduce negative sign on it. You will now remove this 1 over. So you now have, this is ct raised to power negative 1. So plus ct raised to power negative 1. So now this implies that x is the x of t. I'm writing it in full now. This x is the dependent variable, so it depends on t. So I'm writing as x of t equals t plus ct raised to power minus 1. So this is the solution to the given ODE. So thank you so much for being part of this class. See you in the next class.